In normal convolution, one rolls a kernel over an image, gets values at each point, and does some aggregation. So from this perspective, one goes from the high resolution to low resolution. In this paper, they do opposite of this. So this paper is called Top-Down Networks, coarse-to-fine reimagination of CNN from Lelekas, Tomen, Pintea, von Gemert from Delft University of Technology Computer Vision Lab. So they claim that the biological vision uses this low resolution to high resolution approach, while the CNN goes from high resolution to low resolution. And they want to mimic the biological approach. This biological approach, they claim that will be, that they measure that it's more adversarially robust to high frequency noise. So obviously, if you have a low resolution image, if you filter out the high frequencies, then you're going to be more robust. And also because they start with the low resolution, the whole objects are sort of favored to be detected first, and they also show images of this. So how they actually do this? So the principle of the calculation is following. So they have the low resolution, so they use 1:1 convolution kernel. Then they upscale to the resolution of the next step, to the step higher resolution. Once they are there, they do element-wise addition with the high resolution version of the image, and this convolution and upscaled low resolution values. And on this element-wise addition, they do another kernel, sort of this one CNN step, and thus they continue. Okay, so in their experiments they used sort of, they compared, yeah, okay, I'm not sure. So here they have graphs comparing the adversarial attacks. So for me personally, I wasn't that sort of impressed, but it's possible that I'm not seeing it. And okay, so in this section they also show that the explainability is slightly better in their case, because the network sort of detects the objects as a whole, and not sort of like, it's not looking for some sort of individual parts. So what they say here, that on the bottom is their approach, the respective TD network following the opposite path, starting with the holistic representation and gradually adding high frequency in the deep layers. Okay. Okay, so conclusion. In the current work, we visit the architecture's conventional CNNs, aiming at diverging from the manner in which resolution is typically processed in deep neural networks. We propose novel network architectures which reverse the resolution processing of standard CNNs. The proposed TD paradigm adopts a coarse-to-fine information processing pathway, starting from raw resolution information, providing the visual context, and subsequently adding back the high frequency information. We empirically demonstrate the applicability of our TD architectures, and starting from a range of baseline architectures and considering multiple recognition tasks. TD networks exhibit enhanced robustness against certain type of adversarial attacks. This resistance to adversarial attacks is induced directly by the network design choices. Additionally, the high spatial dimensions of the feature maps in the last layer significantly enhance explainability of the model and demonstrate potentially vehicle-supervised object localization tasks. Okay, I hope this was useful. Let me know if you like it. As well, consider using this training generation application with Quizzical, where you provide text and it generates quiz for you. And I hope to see you next time.